Okay, so I think we're ready for our next speaker, Ralf Lange from Bosch, and we're very happy to have you here. So
Be here.
Ralf is going to tell us about how ROS is used in Bosch company. And yeah, I'm also very excited to see what you're going to tell us. And yeah, so happy to have you. And yeah, let's go.
Thank you very much for the introduction. We just found out the screen is not mirrored here, so I have to turn my head from time to time. Yeah, short introduction of myself. I'm chief expert for robotic systems, software engineering at Bosch, and follow the development of ROS2 very actively. Also represent Bosch in the ROS2 TSC, and have been also involved in the EU project that brought ROS2 on microcontrollers called MicroROS. I assume the vast majority here will know Bosch, but for those of you who don't, we are a global supplier of technology and services with more than 400,000 employees worldwide. And Bosch is organized in 4 sectors: mobility solutions, industrial technology, energy and building technology, and finally consumer goods, white goods, and also the power tools, 3D machines, etc. Actually, robotics is scattered over the whole company. We have a couple of products in the industrial technology sector, especially sold by Bosch Rexroth, our subsidiary for industrial market. And consumer goods, we have power tools, and we have Bosch Siemens Hausgeräte, both also active in robotics. I have to say in today's talk, and that applies also to ROS, I focus really on robotics. Of course, we are doing a lot of stuff also in the domain of autonomous driving, automated driving, where ROS also plays a role, but focus today is really on robotics in the closest sense. At Bosch, we have a very long history with ROS. It started already 12 years ago with the PR2 Beta Program. That's the semi-humanoid robot that you see depicted in the top left. 11 of those robots were given out for free, or other way around, you could apply for them. And 10 went somewhere to academia, and 1 went to a company, and that was Bosch at that time. That's why we have this close tie since the very beginnings. We've contributed a lot of software in trying out this robot, doing experiments in household contexts, in manufacturing contexts, and so on. Have been also founding member of ROS Industrial Europe. And things got more serious when we saw that ROS2 really starts and that there are plans for a version 2 focused on the industrial usage, so no longer for research purposes only. That's where we involved very early. We sponsored developers or Bosch employee for more than 5 years to the development of ROS2. He worked directly at the premises of Open Robotics. And since then, we have contributed a number of packages, being involved by multiple EU projects. And I can say from what started 12 years ago with a small research team in the Silicon Valley, is now that we have hundreds of developers who use ROS on an almost daily or really daily basis at Bosch. Now, I thought a bit, what should I address here in this keynote? And since I'm speaking at ROS Industrial Europe, we have a lot of SMEs here from the industrial sector, and I thought of 4 goals for today's keynote. So first, I want to explain a bit typical patterns for the adoption of ROS. A bit more fine-grained what we saw also before. Then illustrate an ecosystems perspective, because I think ROS also plays an important role in connecting ecosystems. Discuss some arguments and quality and speed, and finally motivate you also for contributing to ROS, not just be users of ROS, but really be active in the community. Looking at ROS, I identified 3 types of use at Bosch, and I think this applies to many other companies as well. The first one's, of course, what everybody starts with, that's research, advanced development. We did this from the very beginning. I scan a photo here with the PR2 use case, here with I think it's a router, yeah, or just a vacuum cleaner. And that's what we still do, and where we use ROS in almost all research activity in robotics. The other end is what many companies aim for, of course, bringing ROS really in their robotic product, in their software stack, with the argument that ROS especially brings the non-differentiating part, so when little or no IP is located, the middleware functionality, basic robotic algorithmic functionalities, basic skill capabilities and perhaps some framework also for the deliberation part. But there's also a very valid approach in between, and that's one that I see in our company taken in many projects. That's using ROS as a kind of development tool and environment. So developing products which do not contain ROS, but attaching ROS interfaces that you can benefit from all the tools, that you can store the data, that you have standardized exchange formats for data, and so on. So that's, I would say, a very common use case that I see. And now I see that although we downloaded the latest version of the slides, this is an older version. Can I quickly change this? Otherwise, we might miss some slides at the end. Desktop. Yep. Perfect. Yeah. And here we're back. The graphics was a bit nicer. We also remote control it. That was what I missed. And we use this pattern not only for developing robotics products, but also other products. We have nice examples for tiny sensors where our colleagues then wrap the whole firmware code into a ROS node, simulate it, use the ROS tools to do analytics on the data, and so on. But of course, ROS is not used on such tiny devices, often not from the computational capabilities able to run the ROS stack. The second dimension I see is that ROS connects ecosystems, and I tried to depict this in this graphics. You see in the middle this gray column where really robotics, and around other domains which are not directly robotics domains. And I would like to illustrate here 3 use cases. The first one, of course, that I think you also face, that customers ask for ROS compatibility of individual products. That's depicted in the middle column. As one example, I took our Rocket locator. That's very easy to use SLAM software for LiDAR and typical use cases in warehouses, etc., for HEVs. And that's sold with a proprietary interface. But many customers ask, can you also provide a ROS interface for that? That's what many companies do. We also published a bridge or some kind of driver to connect it to ROS. And it's interesting to see that our customers even contribute to this open source package. The second dimension is depicted here on the lower bar, horizontal, that many existing other ecosystems from completely different background connect with ROS. Unity, for example, game engine for development of computer games, smartphone games, provides now simulation capabilities for ROS and for robotics. Simulink is very similar. The MCAP format, which is now discussed very much for ROS Spec 2, also has a different background. It's not only used with ROS, it's also used in other cases. And one example that I would like to pick out a bit deeper is the function mockup interface. That's actually a standard for co-simulation, so for connecting different simulators, implemented by hundreds of tools, Simulink, Daimler, Wolfram Systems Modeler, and so on. And many years ago, I had a master's student who developed a complex controller with Daimler. And then we stood in front of the problem how to connect this with our existing ROS stack on the robot. And in that context, I developed what I call the FMI adapter, so a tiny ROS package that maps the concepts of this FMI standard, that you have inputs and outputs of simulation modules to this corresponding ROS concept. Honestly, I never wanted to release this open source. It was less than 1,000 lines of code, but a colleague asked me several times, hey, you should do that. It looks so simple. It connects an important ecosystem, namely this functional mockup interface with ROS. And it's interesting to see in the last 5 years, I would say every second or third month, I received an email from somewhere over the globe. Hey, we're using this FMI adapter. I have this and that feature request, or can you explain that to me? Although it's such a tiny package. The last email was in September from Australia. And the third use case, or the third case that I want to, is of course, not only that other ecosystems connect with ROS, it's also that we as Bosch connect our ecosystem, so where we have larger product portfolios with ROS. 2 examples again. Control X automation, that's sometimes called the Android for automation industry by Bosch Rexroth, with various compute platforms, like the one depicted here, also from the yellow series, so the safe modules, and a software stack on top called Control X OS, which can meanwhile also buy separately. And of course, customers also want to bring ROS in this ecosystem, and that's why we connected it. We have even recently made an example with ROS Cool Control, which we also plan to publish in the next month. The other example is the Bodas. That's an safety-rated device for off-road industry, so excavators, tractors, and so on. And recently we brought micro-ROS on this device. With the freedom of interference concept, you could even have a safety-rated function on that device and being able to query the state of that function from ROS, have an interface from ROS or from micro-ROS, and then of course via micro-ROS also connection to standard ROS. If you're interested in details on that, we gave a talk at this year's ROSCon in Kyoto. I linked the video here, and in Springer's ROS book series, there's also a lengthy upcoming book chapter on micro-ROS, 52 pages explaining every detail of the micro stack, and this use case is also described there. I think it appears in February. Of course, I have also to talk about quality and speed, and I'm convinced, and we at Bosch are convinced, that ROS2 makes a difference for us. It relies on proven use standard. There are issues, especially with performance, that has also to do with that DDS, I would say, comes from a very different background, more for very large use with hundreds, thousands of subscribers. Robotics is a bit different, so that's also one of the shady sides where many people experience that the first step is quite difficult, but on the other hand, we have couple of implementations available. You have different vendors available. There are commercial versions, there are open source versions, so you can really choose and select now. That makes a big difference for us. ROS2 also introduced quality levels. It's a tiny thing only that you have in the package now, a quality declaration, description, what the maintainers aim for and how they implement their different quality assurance mechanisms. But that makes a big difference when qualifying such an open source packages then according to our processes for the use in products. So that gives our quality experts already guidelines and something to grasp how this open source software should be handled. And also ROS2, at least the core, comes with much less open source dependencies or third-party dependencies and a much clearer open source documentation, something we are currently working on. We means especially Christian, who's sitting here in the back, how to generate proper copyright files also for the binary packages or for the Ubuntu packages that you download. If you want to join the discussion, I linked here the open pull request on that. And especially with robotics, always keep in mind, it's not only about test coverage, that you have covered all your software with proper unit tests, but the algorithms who are intended for open-ended environments also live from the mileage. So the more the algorithms are used, the more people who contribute improvements, the better are the algorithms than also from requirements that they actually meet. You know that all. You can make fast proof of concepts, MVPs. You have access to talents, but I will also say I have also access to development services. There are many small companies offering development services around robotics, and that makes it different for us. I mentioned already shady sides. Execution management is an ongoing topic. There's a huge number of alternative proposals how to do the executor. And another issue that I see very often is the scattered and incomplete documentation. I think sometimes also rooted in the fact that many people with a strong background ROS1 develop ROS2 without thinking about how to make a documentation for starters. Now, contributing to ROS, you saw this timeline that I showed before already. I see three major patterns why we contribute. The first one is, I think, the most obvious, that you save costs or resources. For example, we contribute a lot to ROS2 control, but we know we will need it, we will use it. Something that exists in ROS1 is also very important for ROS2, something that we develop together with the community. So that's, I think, the standard approach. Trace points is something that we contributed to the core stack of ROS, so that you have LTT and G trace points in the standard ROS2 stack, which we did completely on our own first. It's now actually maintained by a former student who's with Apex AI. Nevertheless, it was originally a development at Bosch, completely alone with no other contributors. It was just to gain efficiency when we work with the ROS2 stack, to bring something in that we use internally, and many others use it now as well. And the FMI adapter, that's something I would say a complete different category, pushing a standard that we as Bosch push anyways, that we use a lot. So reaching something open source where we don't see this cost saving benefit directly, but more this adoption of a standard that is important for us. But even if you don't have a concrete strategy behind contributions, I found this interesting quote from Frank Nagele. Companies that contribute open source are much more productive just by the fact that their employees look deeper into the source code, engage with the community, make small improvements. So yeah, you don't have to have a strategy to start contributing open source. There are good reasons also to start right now. Now, how do we organize it in a huge company like Bosch? I depicted here again the core robotics products, not Control X, what I showed before. So really the products that are, let's say, in the first sense, robots, but there are many other products around, of course, that could be used in robotics. In those products, we find all three types of classes of use of ROS. Some legacy products have been created without ROS at all. The projects behind those products are, of course, in very different phases. And as I said before, it's also scattered to multiple business units. So for challenge for us, how to bring this together and how to form a joint strategy also for the use of ROS. And what we did for that, we copied the model that the ROS2 community uses, or that has been used for ROS2, for the steering of ROS2. Namely, we founded an internal steering committee, technical steering committee, the Bosch Robotics Middleware TSC, which I can share this information, meets once per month, like the external TSC, and meets normally in the day after. So that's also the committee where I bring then decisions and then open questions from the ROS2 TSC, and that mandates me then also to vote in the name of Bosch. So we brought all business units that do robotics together to decide about next steps, decide also about software contributions, what we put open source, what stays inner source, and can also share detail on our infrastructure. We have internally also kind of build farm, similar to the external build farm. It's not the same technological base, looks a bit different, but the process that you release a package, there's a long YAML file listing all the package is the same approach. That brings me back to my original goals. Motivate you also to contribute, to not just be a free rider, but make contributions to ROS. What could be first good contributions? Documentation. If you spot incomplete documentation, then just fix it. Yeah, it's a simple pull request. You can edit the files directly in GitHub. Second thing is review open pull requests. Everybody can do reviews. You don't have to be a maintainer. You can just add your review to existing pull requests. And that's the first step also for developers to get deeper understanding how ROS works internally. Dev and CI tools, that's something that's always evolving. CI environment changes has always to be adapted and fixed, updated. Launch is something that has been reworked completely, and I think there's a lot of potential also to improve, add small utilities to make the launch file smaller by some lean helper functions and so on. And most important, join the working groups. Many don't know. Behind most of the larger, let's say, sub-projects, there's a working group, and the navigation working group, the control working group. They meet once per month, and these meetings are open for everybody. Everybody can join. There's a public calendar listed on docs.ros.org under project governance. You just have to click these meeting events and join the corresponding Teams call or Zoom or whatever type of online meeting software is used. One last slide, what you can expect from Bosch in the next years. I want to share this information that we launched under the lead of the IIT, a new EU-funded project, Convince, where we focus on what I call the deliberation robotics. So this top layer, this orchestrates all the skills, and we see there are many competing technologies. Finite state machines have been used a lot in the past. Now I would say behavior trees are on vogue, planning technology, and so on. And the developers struggle with the complexity there. It has to handle the happy case, the normal task, contingencies, and the real errors. It's difficult to test, it's time consuming. And in this consortia, we want to address this with new deliberation mechanisms. Focuses a lot on behavior tree, but we will also look into learning technologies. And we want to develop tools to support developers in validating and verifying concrete implementations for their robots. We aim especially for stochastic verification technologies, knowing well that a formal proof is hardly possible and often also not necessary. And at least the basis shall be shared as open source software tool chain in the context of ROS. Also thinking of setting up some working group for that. The project just started. Stay tuned. What happens more? If you want more information, it's already a website available at convinceproject.eu. And with that, I'm looking forward to your questions.